We flew from Charlotte to Florida, and our first stop was the beach near Fort Lauderdale. The Portuguese man-of-war would likely be mistaken for a jellyfish. Not only is it not a jellyfish, it's not even an it, but a they. The thin tendrils on a Portuguese man-of-war can extend to 165 feet length below the surface. We also found a lonely sea urchin washed up on the beach. While most sea urchins are not toxic, several in Florida contain venom in their spikes, including the long-spined urchin and the black sea urchin. While not life-threatening, sea urchins can be very painful and cause numbness and swelling that extend far from the wound. Sea urchin spikes are very hard to get out, and a doctor may prescribe antibiotics to prevent infection. This sea urchin was likely safe to touch, but we left it alone anyway. Later, on a reef dive, we did see the black sea urchin and stayed away. And who could forget the hairy coconut? The next day, we drove north to West Palm Beach, where the Blue Heron Bridge connects mainland Florida to the Barrier Islands. We were there to dive beneath the Blue Heron Bridge to see the wide variety of marine life. The most abundant life was the sea sponge. There are approximately 5,000 described species of sea sponge and inhabit all seas, where they occur attached to surfaces from the intertidal zone to depths of 8,500 meters, 29,000 feet or more. The members of one family, the Spongillidae, are found in fresh water. However, 98% of all sponge species are marine. Adult sponges lack a definite nervous system and musculature and do not show conspicuous movement of body parts. Early naturalists regarded the sponges as plants because their frequent branching form and their lack of obvious movement. The animal nature of the sponges, first described in 1755, was confirmed in 1765. After observations of their water currents and the changes in diameter of the opening in their central cavity in the structure, function, and development, sponges are distinct from other animals. One of their most noticeable features is that they lack organs. The cushioned sea star is the most common sea star seen. There are about 1,500 species of sea star. Some live in the intertidal zones and some live in very deep water. Sea stars do not have a blood system, rather a water vascular system. Seawater is pumped into the body through its sieve plate. Sea stars prey on small mollusks, fish, snails, and barnacles. In order to eat their prey, the starfish pries open the bivalve shell with its legs, and one of its stomachs, they have to, come out of its mouth into the bivalve shell where it consumes and digests the meal and then slides its stomach back into its body. Scorpionfish are reef-dwelling fish, and they are great at camouflage, using their mottled coloring and texture to sneak up on smaller fish and crustaceans and swallow them whole in one fast gulp. From short face and big eyes to snout and tail, they are usually 7 to 14 inches long, and they are named for the colorful markings on their pectoral fins, including a dark area with white spots. Because there are venomous spines in their dorsal fins, caution should be used if handling these fish or when diving in rocky areas. The arrow crab is probably the most crazy crab-looking thing ever. The official sciencey name is The arrow crab is mainly a nocturnal scavenger. It eats small feather duster worms and other tiny animals that inhabit the coral reef. The arrow crab is known for being very territorial. The arrow crab is very docile towards divers, but acts very aggressively towards other sea creatures, including its own species. The arrow crab has 8 spidery legs and a head that is exceptionally pointed at the tip. The legs of an arrow crab can be more than 3 times its body length. The body of an arrow crab is composed of many colors. The whole body is covered in a golden brown color, with white, brown, or gold strips running along the crab's body. The end of the legs are dark violet. As the arrow crab grows, it will shed an outer layer of its skin called the exoskeleton. The next day, we dove from a boat off the coast of Fort Lauderdale. Diving from a boat lets us get out into more interesting water, but comes with its own set of challenges. In particular, the strong current in the ocean near Fort Lauderdale. The current in this part of the ocean is produced by the Gulf Stream. The Gulf Stream is a warm and swift Atlantic Ocean current that originates in the Gulf of Mexico and stretches to the tip of Florida, and follows the eastern coastline of the United States before crossing the Atlantic Ocean as the North Atlantic Current. We descend through the bottom current toward the wreck of the Tracy. The boat was deeper than 40 feet, so I couldn't go down all the way, but we got close and we could see the boat. The Tracy was seized by the U.S. Customs for drug trafficking and towed to the Miami River, where it was left abandoned. Eventually, the wreck sailed to Fort Lauderdale to become an artificial reef. In the videos, you can see all the bubbles moving in the water. If we aren't careful, the gases we breathe that are normally dissolved in our blood can become bubbles and seriously hurt divers. This is why we had to do a safety stop. We know while diving that we do not have access to free air, so we have to depend on compressed air we carry in tanks. While breathing the compressed air underwater, nitrogen gets accumulated in our blood. The nitrogen then gradually gets absorbed into the tissues as the dive continues. As we start to ascend, nitrogen starts getting released from the tissues as a result of the pressure decrease that occurs as we go up in the water. Ascending too fast will reduce the pressure very rapidly, and this could cause nitrogen bubble formation in the tissue and blood vessels. These nitrogen bubbles trapped in our body will result in decompression sickness commonly known as the bends. A safety stop is a 3 to 5 minute stop made between 15 and 20 feet during the final ascent of a dive. The greatest pressure change in a scuba dive is near the surface as the diver moves through the last 15 feet of water. This stop gives time for the nitrogen accumulated in the blood to come out slowly and safely instead of as bubbles. Our next dive from the boat was on top of the Oakland Ridge Reef, one of the world's largest reef systems that stretches from Florida to North Carolina. While we were diving, we saw some lobsters. The Caribbean spiny lobster remains hidden in caves, under ledges, and in crevices on the reef surface. During the twilight hours and at night, they are much more active and forage along the reef for small snails and crabs, decaying organic matter in some plants. Caribbean spiny lobsters will eat most things that they find. Unlike the famous Maine lobster, Caribbean spiny lobsters do not have enlarged front claws and are harmless to people. Even so, if a scuba diver or a snorkeler grabs one without gloves, the sharp spines that covers the head and body may cut your hand. While most sea urchins are not toxic, several in Florida contain venom in their spines, including the long-spined urchin and the black sea urchin. We saw this guy tucked into a hole in the reef. Watch your hands. The needlefish is known for its thin, streamlined body and needle-like beak. It is neither the largest nor fiercest fish in the ocean, but the needlefish has claimed human lives over the course of time. Needlefish attack on humans are extremely rare, but the needlefish can easily rupture organs like eyes, heart, intestines, and lungs. When it leaps out of the water, pointing the needle at the potential threat, if the needlefish makes contact with the vital organs of its enemy, death simply becomes inevitable for the victim. Giant barrel sponges are common inhabitants of coral reefs, especially in the Caribbean. Not only are they the largest sponges on the reef, but they are also very long-lived, up to 1,000 years. Like most sponges, they pump water through their bodies to obtain food like plankton, bacteria, and nutrients from the seawater. Sponges are the heroes of the reef. The number of these large sponges pumping and filtering seawater has a big effect on coral reefs where they live. Scientists have found that sponges are the key recyclers on the reef and provide nutrients to all the other reef organisms. Ever since Charles Darwin observed that coral reefs were like oases in the desert, scientists have tried to discover the secret of the food cycle on the coral reef. Now they know that sponges are the key. Biologists think that pufferfish developed their ability to inflate themselves due to their slow swimming style, which makes them vulnerable to predators. During escape, pufferfish use their highly elastic stomachs to quickly ingest large amounts of water and air when necessary to turn themselves into virtually inedible balls several times their normal size. A predator that manages to snag a pufferfish before it inflates won't feel lucky for long. Almost all pufferfish contain tetrodotoxin, a substance that makes them foul-tasting and often lethal. To humans, tetrodotoxin is deadly, up to 1,200 times more poisonous than cyanide. There's enough toxin in one pufferfish to kill 30 adult humans, and there is no known antidote. Sharks are the only species immune to the pufferfish's toxin. They can eat pufferfish without any negative consequences. Bleaching of the coral reef occurs when a change in the reef's environment, like global warming, causes tiny animals in the reef to die. We are lucky because this reef is alive and full of life. The next day, we drove northwest across Florida to a city named Crystal River, located on Florida's Gulf Coast. Today's dive is called a river drift dive, where we let a river's current carry us downstream. The Rainbow River is some of the clearest water I've ever seen. The river emerges from an underground spring and flows toward the Gulf of Mexico. We could see over 100 feet away in the crystal clear water. The Rainbow River had a lot of plant life. There were fields of river grass that looked like meadows blowing in the wind. Strapleaf sagittaria is a submerged grass plant. Unlike most other sagittaria, it can form tall underwater meadows and cool, swift-flowing streams. This plant has dark green ribbon-like leaves. They are about 3/4 of an inch wide and are typically 2 to 3 feet long. The leaves have sharp, pointed tips and 3 to 5 prominent parallel ridges that run the entire length of the leaf. Flowers grow on the branched stalks and can be either above or below the water. During the dive, we stopped in a gravel bed that formed in a location where the water moves slowly. There, we found a lot of snail shells. We also found numerous teeth that looked like they were maybe from animals that died when they fell into the river. Along the bottom of the river, we saw several different kinds of springs surfacing. One type was a sand boil. A sand boil is a sand volcano. Occurs when water under pressure wells up through the bed of sand. The water looks like it is boiling up from the bed of sand, hence the name. Another type is called a popcorn spring. A popcorn spring is when water pushes chunks of limestone out of a hole. It gives the impression of popcorn popping out of it. Sorry, that is all I could find because the internet kept thinking I was saying popcorn! One animal we saw along the way was a double-breasted cormorant. The oldest known double-crested cormorant was at least 22 years old. They have less brain oil than other birds, so their feathers can get soaked rather than shedding water like a duck's. The coolest thing about this bird is that it dives underwater to hunt for fish. We got to see this in action. We also found the fossilized remains of animals from when this part of the riverbed was actually under the oceans millions of years ago. We found a sand dollar fragment put in stone. The term sand dollar refers to a piece of extremely flattened burrowing sea urchins. Sand dollars can also be called sand cakes or cake urchins. We also found the fossilized remains of a tube-dwelling anemone still attached to the rock at the bottom of the river. We saw several springs emerging from small caverns in the bottom of the river. A cavern is where water comes out of the ground and erodes the rock around it into a cave or cavern. One cavern had warm water flowing out of it, and when it mixed with the cool river water, it formed a thermocline. A thermocline occurs where hot and cold water come together and the water looks almost ripply because the light moving through it is bent. Caverns are also interesting places to go into. Long-nosed gar are olive brown or deep green along the upper back and upper sides with silver-white bellies. The young can have spotted sides and fins. The long-nosed gar is generally distinguished from other gars by its longer, slender body and its extended snout, which can be twice the length of its head. The long-nosed gar can grow to lengths in excess of 5 feet. On the last day of our trip, we went to swim with the manatees, where they spend the winter in the warm waters that emerge from caves around Crystal River. Manatees live in tropical water and have very little body fat on them. As a result, they need to eat large amounts of plants to stay warm. Generally, the manatee eats anywhere from 10 to 15% of its body weight in food every day. This is also why they go to warm springs in the winter. Manatees bump noses to see who it is and to tell them hello. Since they have very sensitive hairs on their nose, they can be very useful. Manatees are covered in sensitive hairs, also called whiskers. Each whisker can discriminate between textures with about twice the dexterity of an experienced reader of Braille. Manatees have exceedingly poor eyesight, so it's thought that their whiskers help them find and select the right kinds of seagrasses to eat. Many manatees have large scars from boats not seeing them and hitting them with their propellers. When manatees are in clear water, the animals can see a long way ahead of them. However, because manatees always reside in dimly lit habitats, they are used to not often relying on their clear vision for their daily life. Actually, their vision only helps them make sense of general shapes in the water and avoid colliding with things, and not more than that. Manatee eyeballs are positioned far back on the head and are about half as big as human eyeballs. This, coupled with their large size and weight, means their eyes are too tiny to meaningfully aid them. The closest living relatives to manatees are elephants. Manatees evolved from the same land animals as elephants over 50 million years ago. There is a clear indication of this history. Manatees have toenails. Thank you for watching my video. I hope you enjoyed it.